So the directions on that just basically say find the points of inflection and discuss the concavity of the graph. So if it wants concavity, what derivative am I worried about? Second, all right. So what's the first derivative gonna be? What's the derivative of sine of an angle? Cosine of that angle times, what's the derivative of that angle? 1. So don't forget that. Plus, what's the derivative of cosine of an angle? All right, negative sine of that same angle, but again, the derivative of my angle is just 1. So my first derivative is just cosine x minus what? Sine x. Now, if I went and made a split point table for that, what would I be getting off a first derivative split point table? Increasing, decreasing, maxes, and mins. Okay, but all they wanted was concavity. All right, so what's the derivative of cosine of an angle? Negative sine of that same angle, and the derivative of that angle luckily is just 1 minus. All right, what's the derivative of sine of an angle? Cosine of an angle, and again, the derivative of that angle is just 1. So there's my second derivative. Now, some people might do this. Do you have to do this? No, you do not have to do this. Right, but some people might factor out a negative one who just have what? Sine x plus what? Cosine x. So if I look at it like this, there's one factor. If I look at it like this, there's what? 2. Did y'all just leave it like this? Okay, but it doesn't matter. You get the same answers. Everybody with me? All right, so if we do a negative sine x minus cosine x. Now, split point. Now, this time, though, I'm going from what? 0 to what? And I'm including 0 and I'm including what? 2 pi. That's what that bracket means. Now, split point means where that factor what? Equals what? 0. So I need to know when does a negative sine x minus cosine x equal 0? Now, it doesn't matter which one did you add to both sides or move over, however you think about it. Cosine. So I have a negative sine x is what kind of cosine x? Positive. So do we understand it means that the numbers match, but the signs, SIGNs, are what? Opposites. So in what quadrants are cosine and sine opposites? 2 and 4. Okay. So I know I'm going to have a quadrant 2 answer, and I know I'm going to have a quadrant 4 answer. Because in quadrant 1, they're both positive, and in quadrant 3, they're both what? Negative. So they would match in 1 and 3, but here they're opposites. Now, I've got to think about what my reference angle is. Now, when are cosine and sine the same number values on which triangle? 45, 45, 90. Okay. So if I'm on a 45, 45, 90, we understand that's a 1, 1, and a what? Square root of 2. So in quadrant 2, x is negative, so I'd have a negative cosine and a positive sine 1 over the square root of 2. Quadrant 4, I have a positive cosine and a what? Negative sine. All right, so I know what my reference angle is. My reference angle is 45 degrees. In other words, pi over what? 4. Is everybody clear about that? Okay. So your reference angle is 45 degrees. In other words, pi over. Now in quadrant 2, remember that reference angle is 180 degrees minus your given angle. Right? So what's my reference angle in quadrant 2? Remind me. What was our reference angle was? 45. All right, what do you subtract from 180 to get 45? 135. Okay. Now, 135 has to be some multiple of what? Of 45. So 135 has got to be something times 45. Okay, you got the calculator. What can you multiply 45 by to get 135? 3. How can I do that with my calculator if I don't know? I can just say 135 what? Divided by 45. So I get a 3 here, but what is 45? We've agreed it's pi over what? 4. So one of my split points is going to be what? 3 pi over what? 4. And I'm going to put 135 because we tend to think better in that. Okay. Now, How do I get my quadrant 4 angle? Well, in quadrant 4 angle, my reference angle is 360 degrees minus my given angle. And again, what's my reference? It's what? 45. So what do I subtract from 360 to get 45? 315. Now again, 315's got to be something times 45. So you got your calculator. When you take 315 and divide by 45, what do you get? 7. All right. And again, 45 we agreed was pi over what? 4. So what's my other split point? 7 pi over 4, but we think better maybe in degrees, so 315 degrees. Is everybody okay? All right, you got a calculator or a unit circle or triangles, I mean, whatever makes more sense to you. What's an easy angle between 0 and 135? 90. Is everybody with me? So if I'm doing 90, now I'm not on a triangle, I'm on the unit circle, correct? All right. So if I'm at 90, what are the coordinates right there? At 90. Is it 1, 0 or 0, 1? 0, 1. All right. So I need the opposite of my sign. Right with me? So what's my sign right here? 1. So what's the opposite of that? A -1 minus, what's the cosine right there? 0. What's a -1 minus 0? -1, which is what? Negative. All right. What's an easy angle between 135 and 315? I'm liking this unit circle. What's an easy one? 180 or what? 270, whichever you prefer. Is everybody with me? All right, suppose I decide to do 180. What are the coordinates right there? -1 what? 0. Everybody good? All right, what's my sign right here? 0. What's the opposite of 0 though? It's still just what? 0. Minus. All right, what's the cosine right here? -1. What's the same thing as minus a negative? Plus a positive. So what does this final answer come out to be? 1, which is positive. Now, this is one of those where there's not an easy unit circle angle between 315 and 360. Is everybody with me? So that's where I said, if it were me, I would just go to my machine and I would go to my mode key and I would just change it over to degree mode because we tend to think better in degrees. And I would literally just type something in there. And by that, I mean, how about 320? Is that okay? And that between 315 and 2 pi? So what am I going to type in? I'm going to type in a what? Negative. I'm going to type minus. Negative sign of 320. And then minus a cosine of what? 320. What kind of answer came up on your machine? A negative. Now, if you typed in 350 degrees, it would be a different negative answer, but it would still be what? Negative. Now I'm going to go back and change it back to radians before I forget. Otherwise, I'll freak out later. So you tell me, where does this thing concave up? From what to what? Where's my final answer? What? Positive. It's only one row. Is everybody with me? So where's my final answer? Positive between what? 3 pi over 4 and what? 7 pi over 4. 3 pi over 4 to 7 pi over 4. All right, where does this thing concave? That's up. All right, where does it concave down? Between what? 0 and 3 pi over 4, or in other words, union what? 7 pi over 4 and what? 2 pi. Now, they ask you about inflection points. Inflection points is where your concavity changes. So where does your concavity change? Well, it changes from down to up right here, doesn't it? So my inflection points are going to be 3 pi over 4 comma something and what? 7 pi over 4 comma something.
The
Question.
zero and 2 pi including the
Say that again, I'm sorry.
0 and 2 pi should be including pairs.
Here,
0 and 2 pi, yeah.
right, in other words, yes, I do need brackets on this one and on this one. All right, they're not gonna make a big deal about that, because their intervals are gonna be open most of the time, but technically I think that's a good thing to do. Okay, now, how do I get the y coordinates right here? I plug them in where? The original, all right, so what's the sine of this angle? Well, I know it's got to be the reference angle. I erased it. All right, my reference angle was 45, so I know the number is 1 over the square root of 2, correct? All right, but is it gonna be positive or negative in quadrant 2? It's gonna be what? In other words, what about, I need to know what the sine of 3 pi over 4 plus the what? Cosine of 3 pi over 4 is. Is that right? Is everybody okay? Because I'm plugging it in where? In the original. All right, what's the sine of 135 degrees gonna be? You tell me.
Yeah, the square root of 2 over 2.
Yeah, square root 2 over 2 or 1 over the square root of 2. Because it's the same thing as the reference, isn't it? What sine? 1 over what? Square root of 2. And then I've got to adjust SIG in, but I'm in quadrant 2, and y is what in quadrant 2? It is positive. Is everybody with me? So that's how I know this one's 1 over what? The square root of 2. What's that one? What's the cosine right there? Well, the numerical value is still what? 1 over the square root of 2, but it's cosine x or y? X. And what is x in quadrant 2? Negative. So what does the answer come out to be? 0. Now, our inflection point is always going to have 0 for y values. No, this one just happens to. All right. Now I've got to do the same thing, but instead of 3 pi over 4, I've got to have what? 7 pi over 4. But the same kind of thing is going to happen on this particular graph, because the reference angle is still 45, isn't it? But this time, this one is what? Negative, and this one's what? Positive. But I don't want you to think inflection points always have 0 for y values, because they do not. So that's where it concaves out, concaves down, and that's your inflection point. Is that okay for everybody? Good? All right. Let's look at, what's the other one, 33? The other one's got an E in it or something? L-N, all right. So let's see what we've got. All right, we've got x minus the natural log of x. Okay. Now again, if they want concavity, we're worried about which derivative? Second derivative. All right, help me find first derivative. All right, what's the derivative of x? 1. All right, how do you find the derivative of natural log of something? What goes on the bottom is what follows Ln. Do you remember that? So I'm gonna put what? X. And then what goes on top is the derivative of that denominator. So what's the derivative of x? 1. So there's my first derivative. And again, that would help us with increasing, decreasing maxes and mins. All right, second derivative. All right, what's the derivative of constant? 0. And then minus. Now, what rule am I going to have to use if I leave it in this form? Quotient. You could pull it up and make it x to the -1 and use power rule. That's probably what I would do, and I'm going to use quotient rule for practice. Okay. You start on the bottom. What's the derivative of that top, that numerator? 0 plus or minus quotient. Minus, and I copy down the top. What's the derivative of that bottom? 1, and all that's over the bottom. What? Squares. Now I've got 0 minus something, so I've got a negative. Now I've got a 0 minus a 1 over x squared. Is everybody with me? So be careful with your SIGNs. All right, what's 0 minus 1? What's that end up being? A what? -1. But what's minus this negative going to give me? a positive. So what's my second derivative? 1 over x squared. Now, you may not even need a split point table, but I'm going to do one. I see two factors. I see a 1. Now, does 1 have a split point? Is it ever 0? No, it's just 1 all the way across. Positive number. All right, what's my other factor? X squared. All right, that is 0 sometimes. When is x squared 0? When x is what? 0. But if I pick a number to the left, like a -4, and I square it, it's going to be what? Positive. If I pick a number to the right, like 2 and square it, it's still going to be what? Positive. So I'm supposed to be dividing them, but what's a positive divided by a positive? Positive. So what does that mean? It's always concave and what? Up. So it concaves up, negative infinity to what? Infinity. You can say always concaves up, however you want to say it. Now, if the concavity doesn't change, they're going to have an inflection point. Is the answer in the back wrong, Gracie?
It's different if I'm thinking of the same one. It says concave upwards 0 to infinity.
All right, we're going to talk about why.
Okay.
All right, now here's why. So you write that down and then you stop and think. In your machines right now, I want you to type the natural log of a -2. What happens when you do that? Error. You can only take the natural log of positive numbers. Okay, here's why. Remember what natural log means. And this will take care of itself in a minute, because the first thing you're going to have to do for me when you're doing one of these from start to finish, the first thing you're going to find is the domain. All right. So if you do the natural log of a number, what is natural log of the same thing? It's log with the base of what? E. Now look what would happen if you typed in like a -2. Now isn't E a number? What's E about? Do you remember? About 2.71. Now remember what this means. This means this base to that has to equal that. Are you ever going to be able to raise a 2.7 to any number and turn it negative? What? No. That's why there's no such thing as a natural log. You can't raise 2.7 to anything and get a 0. So the domain on natural log is always what kind of numbers? Positive numbers. So because this isn't defined on negative, this is going to turn into what? 0. Does that make sense? Okay. But that will be already evident for you, because the first thing we're going to talk about in a minute, I'm going to make you do is domain. So you would naturally take care of itself. Okay. All right. Let me look at one more real quick, and then we're going to keep going. Let's see. 19 seems to be the other one. Is it 19 on that same page?
Yeah.
Where it's got x times x minus 4 cubed? Okay. Now, I would not recommend this, because could you multiply the whole thing out? Yeah, so if you got stuck, now, why would I not recommend that? Well, don't I have to have it in factor form at the end? So it seems kind of silly to multiply it up and then what? Factor it back. Seems like a lot of wasted effort, but sometimes when we get desperate, we just have to do that. All right, and here's one of the reasons. What's the highest power going to be when you multiply that thing up anyway? Well, what's going to be inside of this is a what? A cube and some other things, right? What happens when you say x times a cube? You'll get x to a what? Fourth. So when you take the first derivative, it's gonna go from a fourth degree down to a third. And then we take the derivative again, we go from a third degree down to a what? Second. I could probably factor a second degree. But if they were like a sixth degree, that'd be a disaster to multiply it out. Does that make sense? All right, I'm not gonna multiply it out. All right, help me. What do I do? What rule am I about to have to use? Product. So I copy down the first one, correct? Now I've got to do the derivative of the second one. All right, so what rule am I going to use when I do the derivative of the second one? I'll have to use that chain rule, that power rule, that extended power rules. Everybody, what happens to that power? Comes down. What happens to my expression? Stays the same. What happens to my power? Goes down by 1. Then I've got to do the derivative of the inside. But luckily, what's the derivative of the inside? 1. But always at least do it in your head. All right, plus or minus on product rule. Plus. All right, now I've got to copy down the second thing. So I'm going to copy down x minus 4 what? Cubed. And then what's the derivative of this first thing? Luckily, it's just a what? A 1. Okay. So I've got an x. What kind of x? Actually, I've got a what? 3x. And then I've got an x minus 4 what? Squared. And then plus I've got an x minus 4 what? Cubed. Everybody okay? Now, this is me being me. I'm not saying it's better, it's just me. I probably would go ahead and factor something out and have another product rule to do. What can I pull out of there? Or wouldn't y'all do it this way? Because now I'm going to do the product rule here, I'm going to do a power rule of it. That's a lot of stuff. All right. What can I factor out of both of those? X minus 4 squared. All right, what's that going to leave in this first one? Just a what? 3x. Plus, what's that going to leave me over here? Another x minus 4, like to the first, so to speak. That makes sense to everybody? So I've got an x minus 4 squared, and then what does this simplify into? 4x minus 4. So that's my first derivative. Okay. Now let's go do second derivative. What rule am I going to have to use on second derivative? Or this one, product rule. So what am I going to do? I'm going to copy down the first one. So I'm going to copy down x minus 4 what? Squared. All right, what's the derivative of this second one going to be? Just a 4. Does everybody see it's just a 4? All right, plus or minus on product rule. Plus, then I copy down the second one, so I'm going to copy down 4x minus 4. All right, so help me. How am I going to do the derivative of this first one? What rule am I going to have to use again? That is what that extended power rule. What's going to happen to that 2, that power? Comes down. What happens to my expression? Stays the same. The power goes down by 1. Now, luckily for me, again, what's the derivative of that inside? Right. So I've got a 4 times an x minus 4 squared. Plus, what do I have now? Well, I've got a 2. I've got an x minus 4, and I've got a 4x minus 4. See if I did that right, because I'm bad at making careless error. Is that what y'all got? Now, I'm going to factor it. I've got to have it factored fully if I want to do a split point table. What can I pull? What do it small things at the time? What can I pull out first? Don't I have a 4 and a 2? So what can I pull out? A 2. All right, don't I have an x minus 4 and an x minus 4? So am I going to pull out a single or a square? Single. All right, so what am I going to multiply 2 by to get the 4? 2. I need 2 of these and I've got 1, so I need another what? X minus 4. Do we agree? And then plus, I need a 2 and I have a 2, so that's good. I need an x minus 4, I have an x minus 4, so that's good. What am I missing? 4x minus 4. So I've got a 2, an x minus 4. Then I've got a 2x minus a what? 8 plus a what? 4x minus a 4. So clean that up for me and tell me what I get. What's 2x plus 4x? 6x. And then I've got a minus what? 12. Now, when I look at that, I see 3 factors. Can you finish it? Could you do this? Could you pull a 6 out of this and then say 6 times 2 is 12? That's probably what I would do because I like small numbers. Does everybody understand what I'm saying? I'm saying you can do it this way. But if you pulled a 6 out, that would give you an x minus a what? 2. And then I could say 6 times 2 and get what? 12 and have an x minus 4 and a what? X minus 2. So this isn't going to have a split point. It's going to be positive what? All the way across. That's going to have an easy split point of 4. That's going to have an easy split point of what? 2. And so it should be real simple to finish out. Okay. So if you need help finishing that out or help with one of the ones we didn't get to, just come see me. Right. Now, before we kind of do what we're going to do today, I want you to go back to your notes from last time. Okay. All right, back on your notes from last time, here's what I want to talk about for a second. The last example that we worked, we did like the increasing, decreasing, maxes and mins, and we almost finished the concavity, correct? What was that function? What was the original function on that
It was x squared plus 1 over x squared minus
one? X squared plus 1 over x what?
squared minus 1.
Minus 4? Okay, now, let me show you something. All right. All right. We're going to work our way down to this, and what we're going to go over today is horizontal asymptotes. Okay, that's going to be the last thing. But I want to go back and fill these other things in first. All right, then when we get down to horizontal, we're going to go do horizontal asymptotes. And then we're going to graph this thing. All right. So what we're going to do today is we're going to kind of finish out and talk about horizontal asymptotes and then put it all together and draw a rough sketch. All right. So you help me. So the first part we didn't finish, we didn't fill the first part out because we've already learned how to do that. So let's go back and review. When am I gonna be in trouble on my domain on this rational function? When that denominator's what? Is 0, right? So when I have a rational function, remember, we set our denominator equal to 0. So I've got to worry about when x squared minus 4 is what? 0. Now, I tend to factor it so I don't leave any out. What does x squared minus 4 factor into? X plus 2 and what? X minus 2. All right, so when is that thing equal to 0? When either x plus 2 is 0, right? Or when x what? Minus 2 is 0. So what's the solution to this first one when x is a what? -2. What's the solution to this one when x is a what? Now, is that my domain, 2 and -2? What's my domain? Everything but what? 2 and -2. Now, when you turn to the back of the book, they're going to go like this. Negative infinity up to -2, union, -2 to 2, union, 2 to infinity. What do those parentheses mean? Include or exclude? Exclude. So this says forever to the left till you get to -2. Don't include -2 though. And this says start, but don't include, you see what I'm saying? Now, for me, if you would rather write it this way, that says the same thing. That says all real numbers except x cannot be what? -2 or what? 2. I don't care. I understand algebraic notation, I understand interval notation, but the book's going to have what? Interval notation. Okay. So as long as I don't get 2 or -2, life is good. All other numbers are going to give me an answer. It may give me an ugly answer, an irrational answer, but it's going to give me an answer for the number here. All right. Remind me what kind of intercepts I'm talking about here. X-intercepts and what? Y-intercepts. So I would expect you to distinguish between the two. X-intercepts and Y-intercepts. Now, how do you find X-intercepts? Remind me how I find X-intercepts. I let what be 0? Y. So it's the opposite. On X-intercepts, that's where the graph crosses the X-axis. But where the graph crosses the X-axis means the Y-coordinate's got to be what? 0. So where is this Y-coordinate 0? Well, I want you to use, like I said, some logic. Doesn't that say a fraction equals 0? When does a fraction equal 0? When the numerator is 0. When is x squared plus 1 ever going to be 0? When x squared would have to be a what? -1. What's that tell me? X squared is not ever what? So what does that mean about the x-intercepts? There's not any. Apparently I don't have any of those. So that thing's never going to cross the x-axis. That's good to know. All right, remind me how I find y-intercepts. X is 0 now. So I'm going to go up here and let x be 0. So what does that simplify into?
Just
1 over a what? -4. So that's a negative what? 1/4. Now, intercepts are points, and points have how many coordinates? 2. I know that which part, what does f of x mean? That's y. What's the y part? -1/4. What's the x part? You just told me it was what? 0. So you'll have to show me. I'm trying to keep it on one board. So, but you'll just leave all this work and show me. That way, if you make a careless error somewhere, you get partial credit. Now, what kind of symmetry am I expecting you to check? What kind of symmetry do we talk about way on test 1? X, Y, and origin. All right, x-axis symmetry, y-axis symmetry, and origin symmetry. So I would expect to see you check for both on your test. All right, remind me, how do I check for x-axis symmetry? What do? I replace what?
Well,
All right, so I've got, was x squared, is it plus 1
Yes.
over x squared minus 4?
Yes.
Okay. So I replace, what'd you say, y with a what? Negative y. All right, now that doesn't say y, but f of x is the same thing as what? Y. So if it bothers you, just make it a y. So if I had a negative y, is x squared plus 1 over x squared minus 4. Is that the same thing as the original? It's not, is it? What if I multiplied through by -1? Well, that would fix this side, but what? It would mess up that side. So apparently what? Yes or no? No. All right, how do I check y-axis symmetry? Remind me what I replace. X with a negative x. All right, so instead of squaring x, I'm going to square a negative x. Right. So y, what happens when you square a negative x? It's just x what? Squared. And again, when I square this negative x, it's just x what? Squared. Is that the same thing as the original up there? Yes, so that's a big what? Yes. How do I check origin symmetry? Do you remember? What do I replace? Both. So that y is going to be replaced with a negative y, and that x is going to get replaced with a negative x. Okay. So I'm going to have a negative y is going to be x squared plus 1 over x squared what? Minus 4. Does that look like the original? What if I multiply through by -1? That would fix the left side, but what? Mess up the right side. So another what? No. So do I have any symmetry? Yes. Yeah, what do I have? Y-axis symmetry. But that's kind of your support for that. Now, we already did the increasing, decreasing, maxes and mins, didn't we? What was our increasing and decreasing? Go back and tell me what it was.
Increasing negative infinity to -2, union -2, 0.
Okay, and then we decrease from what?
0 to 2, union 2 to infinity.
Now, we went down here to relative maxes and mins. Now, this thing's going down, and then at -2, it still keeps going what? Down. So do I have a max or a min there? If something's going down, it keeps going down, what? Nothing. But at 0, it's been going up, and suddenly it turns and goes what? Down. So what might I have at 0? A max or a min? A max. So I've got, I think, a relative max at 0 comma something. Now, how would I know what the y value is? Plug it in. Now, the funny thing is, though, I've already got it. 0 what? -1. Now, what would happen if I tried to take that 0 and I plugged it in and there wasn't a point there? Then I'd have to start erasing. Does that make sense? So if something weird was happening at 2, I might be in trouble. Because remember, my domain skipped over -2 and what? And 2. Now, we had started concavity, correct? Did y'all finish it? All right, give me my factors for second derivative and let's finish it real quick. All right. What was my second derivative? So we don't have to go back through it.
-2. Times -3x squared minus 4.
And that was over.
X plus 2 cubed times x minus 2 cubed.
Everybody okay? Now, how many factors do y'all see? Now, let me tell you what I would like. I'm not going to do it, but what I would likely do. It's not better, it's just might be more succinct. I would probably factor a negative out of this one. and then multiply by a -10, so I had a bunch of positive stuff. Is everybody with me? But you might not think to do that, so I'm not gonna do it. So what's one of my factors up here? -10. Does that thing have a split point? What? No, it's just always what? -10 is always negative. All right. All right, now I've got another one. I've got a -3x² minus 4. All right. When is a -3x² minus 4 going to be 0? Well, that's going to be true when the -3x² is what? Is 4, isn't it? So what's that mean x² has to equal? 4 over a what? -3, so that's a negative what? 4/3. Is a squared number ever going to be negative? No. So what does that mean? Well, that means that this sign's not going to change. It's either always positive or always what? How can I decide whether it's always positive or always negative? Just plug something in. What's an easy thing to plug in? 0. So what's 0 minus 4 going to get me? Negative. Thing's always negative. If you plug in a 1, you get a -7 instead of a -4, but it's still what? Negative. So anything you plug in there, the answer is going to be negative. All right. I've got another factor that's x plus 2 what? Cubed. All right. X plus 2 cubed. When is that thing going to equal 0? -2. Okay. So somewhere on this is a -2. Okay. Give me a number smaller than -2. I'm just putting the pink into the pink. What's a -4 plus 2? -2. What happens when you cube the negative? It's going to be negative, isn't it? What's an easy number bigger than -2? 0. All right. What's 0 plus 2? 2. And when you cube that positive 2, it's going to be positive. All right. What's another factor? X minus 2 cubed, isn't it? All right, what's the split point for x minus 2 cubed? 2. Is 2 to the left or the right of a -2? Somewhere to the right. All right, give me an easy number smaller than 2.
0.
What's 0 minus 2? What's happens when you cube that negative again? It's going to stay what? Negative. All right. If I pick a number bigger like 5, 5 minus 2 is 3. What happens when you cube that positive number? It's going to be positive. Okay. So I've got an even number of negatives here. So if I'm multiplying or dividing, what's that mean that final answer is going to be? Positive. All right, I've got an odd number of negatives here. So if I'm multiplying and dividing, that means that's going to be negative. And what's this going to be? Positive. All right. So where does this thing concave up? Where's the final answer positive?
Negative
infinity to what? -2 union what? 2 to infinity. Do you understand where that final answer is positive? It's concaving up like a cup sitting up. Where is it concaving down?
-2 to 2.
Okay. Now, don't you have possible inflection points where the concavity changes? So where does that concavity change? At -2 and what? 2. Now, if you don't know this, you're going to put -2 comma something, and you're going to put 2 comma something. What happens when you try to plug in 2 and -2 into that original? Doesn't the bottom go to 0? See, remember back up here, we said what's not in our domain? -2 and what? 2. So if it's not the domain, there can't be a point there. So our only 2 candidates, what? They don't work. So what does it mean about inflection points? None. All right, remind me how we find vertical asymptotes, because that was on the last test. All right, how do I find vertical asymptotes? Where the what? Where that denominator is zero and the numerator what? Isn't zero, okay? My original. When is x squared minus 4 gonna be 0? Didn't we just do that a second ago? So what are my candidates? When is x squared minus 4 gonna be 0? At -2 and 2. But now I've got to worry about the numerator, don't I? So I've got to do f at -2 and f at +2. Now I already know what happens on the bottom of both. The bottom goes to what on both? 0. What happens when you put a -2 in this numerator? What's a -2 squared? +1 is 5. What happens when you put a 2 in there? You're still going to get a what? A 5, right? Does that meet the condition or not meet the condition? It meets it because the bottom goes to 0 on the top, what? Doesn't. So I've got how many vertical asymptotes? 2. What are they? X equals what? -2 and x equals what? 2. They're vertical lines. In the form of a vertical line is always x equals a number. Okay. Now, so the only thing we have left to fill in is this what? Horizontal asymptote. Once we get this horizontal asymptote filled in, we're going to try to draw this thing. That's the fun part. Okay. All right, so let's go look in your books then about these horizontal asymptotes. All right, first of all, let's just use kind of some common sense. Right? This is kind of a classic graph. Right? As I come toward this x-axis, this line's getting smaller and smaller. It's dropping, 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 but it's never going to touch this x-axis. All right, now I'm only doing kind of the positive half of this. Because if I put in a 10, it's going to be 1/10, right? What if I put in 100? It's going to be what? 100. If I put in 1,000, it's going to be what? 1,000. So does this make sense to you? What's happening to my x values a second ago? What was I doing to these x values? 10, 100, right with me? 1,000. What am I doing to these? These values are getting what? Bigger and bigger and bigger. Those x values are getting bigger and bigger and what? And bigger. Is everybody with me? So basically what they're telling you over here is, on this graph, what are these y values doing? They're getting smaller and smaller and what? Smaller. So from our picture and from our table, what do we think this answer is? What are these y values getting closer and closer and closer to? 0. Now, do they ever get there? No, but that's what limits do. Limits get closer and closer, but never what? Get there. Now, here's the catch. Here's what your book basically says then. If you're doing the limit as your x gets bigger and bigger and bigger of some function, what happens when you get a number answer? When you get a number answer, do you have or not have a horizontal asymptote? Apparently what? You do. Everybody with me? Well, what is your horizontal asymptote going to be? Well, what are the forms of vertical asymptotes? X equals a what? Number. So horizontal asymptotes are going to be what? Y equals a number. Well, what number? That one. So y equals that number is gonna be a horizontal what? Asymptote. Now, suppose my graph looks like this. Put a different color. See, suppose right here at 2, suppose the graph looks like that. Well, I don't know what the expression of it is, but I know that when X gets bigger and bigger and bigger, or whatever that red graph is, what's the Y getting close to now? It's not getting close to 0, it's getting close to what? To 2. So sure enough, there would be a horizontal asymptote on this graph, and what would it be? It would be Y equals what? 2. Now, what happens if you don't get a number? Well, then that means you don't have a horizontal what? Asymptote. Because it might be when you're looking at your graph, maybe as X gets bigger and bigger and bigger, maybe you got a parabola. You know, as X gets bigger, what's Y doing? It's just getting what? Bigger and bigger and bigger. It may be that you got a parabola going down. Well, then when X is getting bigger and bigger, what's Y doing? It's getting what? Smaller and smaller and what? Smaller. Think about cubic curves. Everybody with me? All right, so when they go up and down, it's not getting close to anything. It's jumping around or always going up or always what? Going down. So how are we going to find if we have horizontal asymptotes? We're going to have to take the limit as X increases without a bound. Now, remember that graph I put up here a second ago. Y equals 1 over X. What happens if X is 0? It's undefined. That's why the top half of the graph looks like that. But now think about a t-table. Could Y be negative? And could X be negative? So if X is a -1, what's Y going to be? A -1. What if X is a -2? What's Y going to be? A negative what? 1/2. If X is a -3, it's a negative what? 1/3. So do you understand? It's going to look like that. I've got a hyperbola. Because when X is going in the negative direction and the absolute values are getting bigger, though, this Y is what? Shrinking. So I'm not going to be able to just check positive infinity. What else am I going to have to check? Negative infinity. So I'm also going to have to check the limit of f of X as X approaches negative infinity and see if I get a number. Now, sometimes if you get a number, they come out to be the same, but sometimes, especially on some transcendental functions, you can get 2 different answers. So when we do them, either in your head or on paper, I need you to go back and wonder what happens if I was approaching negative infinity instead of what? Positive infinity. All right. So here's kind of the trick to it. So on page 240 in your books, they give you a definition of a horizontal asymptote, and that's what it says. The line Y equals L is a horizontal asymptote of the graph of F when the limit of f of X as X approaches negative infinity is L, or the limit as X approaches positive infinity of your function's L. So all they did, instead of putting a number right here, they just put a what? An L. And so it would be Y equals that what? L. I just put number and that number in place. Just to make it a little more clear. So basically theorem 410 says, so if you want to find horizontal asymptotes, you're going to have to take the limit. All right. And then we're going to talk about a couple of shortcuts. Now, all right, here's what it says basically on page 241. See if this makes sense to you. I'm approaching infinity. So that means the x's are getting what? Bigger and bigger and bigger, all right? What if I had a 5 over an x? What would happen is that bottom got bigger and bigger and bigger. 5 over 10, 5 over 100, 5 over 1,000, 5 over 1,000,000. What's that answer gonna equal? What am I gonna get close to? Yeah, think about it, x and y. What if x is 10? 5 over 10 is what? A half. In other words, point what? 5. If I have 100, I'm gonna have 5 over 100. If I had 1,000, I'd have 5 over 1,000. In other words, see, what's that doing? It's going to what? 0. What if instead this were x squared? What would that answer be? Well, what if you put a 10 in there? You'd have 5 over 10 what? Squared. What if you put 100 in there? What happens when you square 100? I'm not gonna get 100, I'm gonna get what? 10,000. Is everybody with me? Do you see that you're just going to 0 what? Faster. What if it were cubed? Even what? Faster. So here's what your book says. They put a C for constant. So, all right. So it says C can be any real number. Has it got to be positive? What? All right. It says then, and R has to be, it says a positive what? Rational what? Number. If you've got x to the r, this is going to be what answer? 0. As long as r is positive. What if r is a half? That's positive rational number, isn't it? Do you see it would just slow it down some? It wouldn't be as fast, you see what I'm saying? Or we're just gonna still go to 0, but it's gonna change it now. You see what I'm saying? All that's doing is changing the speed. Speed it up, what? Slow it down. Why can't r be negative? Why couldn't I have the limit? Is that supposed to be infinity and I had a 5 over an x to the -2? Why is that not gonna work? Why is that not gonna be 0? Because how do we rewrite this? How can I make that a positive? Bring it where? Up. So that would be 5x what? Squared. So now what if x is 10? Well, 10 squared is what? 100, and 5 times 100 is what? 500. Well, what if I put in 100? Well, now when I square 100, I'm going to get 10,000. So now I've got what? You see why you wouldn't get 0 if x was a negative, if that power was negative in the denominator. Now, the reason that's going to come in handy is this. There are different ways of working this problem. This one doesn't bother anybody. If your function was something like 6x squared minus 10x plus 11. When I've got a little polynomial, what's going to happen when this x gets bigger and bigger and bigger? What's this answer going to eventually do? Get what? Bigger and bigger. I mean, after a while, this squared number is going to be way more than 10 what? Times that number. Is everybody with me? Well, am I going to get a single value like 2 or square root of 7 or 4 or a next? I'm just going to get this answer, just going to be getting what? Bigger and bigger and bigger. So polynomials, it's not really a lot of work. You're not going to get a number answer on those. Everybody okay? When it gets a little weird, it's when you got a rational function. What do I mean by that? So here's the problem on that one. When X gets bigger, isn't that numerator getting bigger? What's that denominator also getting? Bigger. Well, now it matters who's getting big, who's getting bigger faster.
Is that a zero?
So what if the top is getting bigger way faster than the bottom? The fraction's getting bigger. Right? It'd be going to infinity. I wouldn't have an asymptote. What though if the bottom's getting bigger way faster than the top? Then the fraction's what? Getting smaller. It might be going to zero. What if the top is getting faster almost twice as often as the bottom, almost double? Well, then that fraction might be going to 2. If that bottom's getting faster about 3 times as much as the top, it might be going to 1/3. So I can get any kind of answer when one's getting bigger and the bottom's getting what? Bigger. So what they tell you is a little bitty, basically, kind of a common sense suggestion to you, and that is this. When you got a rational function and you're taking the limit as you're approaching infinity or negative infinity, here's kind of something that's going to make your life a little bit easier. I want you to divide every term by the variable raised to the highest power in the denominator. And I didn't say the highest power in the fraction, I said the highest power in the what? Denominator. And I can do that basically. It goes back to those limit rules we went over at the very beginning of the semester. Because there's something called undefined and there's something else called indeterminate. All right. Now, we know what undefined means. When's a fraction undefined? Remind me. When the bottom 0 and the top what? Isn't. Okay. When we got in trouble before on limits, remember sometimes we'd have a 0 over a 0? What was our trick then? Our trick was to do what? To factor. Do you remember that? That was one of our tricks. It's still a trick. It's just sometimes that trick what? Doesn't work. Like I can't factor this. I'm kind of nailed. So what's also true is instead of working it the old way, I can somewhat work it this new way. Now here's what I mean. What's the highest power of your variable in that denominator? X what? Squared. Even if this were 6x squared, I'm not worried about 6x squared. I just want the variable raised to the highest power in the bottom. So what's the highest power in the bottom? X squared. Then I'm going to divide everything by x squared. So I'm going to take this numerator and I'm going to divide everything in it by x squared. And I'm going to take this denominator and divide everything in it by what? X squared. We can use a different color that might make it look better. So if I take a fraction and I divide the numerator by a number and the denominator by that same number, I'm still going to get a true statement. Everybody with me? So I'm okay to do that. Now, then I want you to simplify. All right, here's what I mean by that. What's x divided by x squared? What will that simplify into? What can both of those be divided by?
1/x.
That's 1/x. Does everybody understand that that reduces to 1/x? Can I simplify 6x squared over x squared? Yeah, what's that simplify into? 6. Can I simplify 3 over x squared? What? No. So after I do this, I simplify. And then I do the limit. Now, I will write way more steps than you have to write. Do we remember that the limit of a fraction is the limit of the top over what? The limit of that bottom. Remember those rules we went over the very first time. Now, do we remember? I come over here. That the limit of a sum is the sum of the limits. I can separate them. Do y'all remember that? Are we good? Now remind me of something. Do each one separately. What's the limit of 1/x? What happens when this bottom's getting bigger and bigger and bigger and bigger? What's the fraction doing? It's going to what? 0. Remember, that's the one we talked about. If I have the limit as x approaches infinity of a c over an x to a positive power, that's always going to be a what? So do we understand, even if this c is like 1,000,000, eventually that bottom's going to be way bigger than what? 1,000,000. Does that make sense? Even if that number's huge on the top. So does it make sense why that numerator is going to 0? What's the limit of a constant no matter what you're approaching? The constant. What's happening here? What's this thing going to again? Just going to 0 faster, isn't it? So what's 0 over 6? What? 0. Is 0 a number? Yes. Now, if they just want the answer to this problem, this answer is just what? 0. Everybody with me? A separate question might be, then would this have a horizontal asymptote? The answer would be what? Yes. How do I know it has a horizontal asymptote? Because when I took the limit as I approached infinity, I got a what? A number. And the horizontal asymptote would be what? Y equals what? That what? Number. Okay. Now I want to flip back to this problem for a second. I want to know if this has a horizontal asymptote. How do I know if it's got a horizontal asymptote? What do? I take the limit of that as x approaches what? Infinity. Now, do we understand that when x gets bigger, that numerator is going to get bigger? And do we understand that when x gets bigger on the bottom, that denominator is going to get bigger? So what's my trick here? I don't know which one's getting bigger faster, so I'm going to have to do what? Divide everything by what? X squared, because that's the highest power in the what? Denominator. We're going to do one in a second that's a little different. So everything is going to be divided by x squared. So I just go ahead and put everything over the x squared rather than doing it in like 4 steps. And then I clean it up. Okay. What's x squared over x squared clean up into? 1. I can't clean up 1 over x squared. Right? That doesn't reduce. X squared over x squared, what happens? It cleans up into a what? 1. And I can't clean up 4 over what? X squared. Now, I'm gonna do the limit of each one. What's the limit of this constant? The constant. What's the limit of 1/x²? When that x gets bigger and bigger, what's 1/x² gonna go to? 0. Again, the limit of a constant is the constant. And what's that gonna go to? 4/x² is also just gonna shrink down to what? 0. What do I get? 1. Did you get a number answer? Then do you have a horizontal asymptote? What is it? Y equals 1. Now, in your mind, I want you to do negative infinity and see if that changes anything. What if x were negative? Well, if x were negative, is that going to change the limit of 1 being 1? No. Is that going to change 1/x² going to 0 or 4/x? No. So it won't. We'll do one next time where it's different. Is everybody with me? Now, leave that for just a second. And I want to go back over here for a minute real quick, and then we're going to try to do a rough sketch. It'll be over. What if instead this had been x cubed? If this had been x cubed, what would everything be divided by? Still what? X². All right. So what would that top clean up into? X. That's still going to clean up into a 6 and a what? 3 over a what? X². Now, I did not do this. All right. So I'll just deny it if you tell me, if you write this down. All right. Now, what's the limit of that constant still going to be? That constant. What's that still going to go to? But what's going to happen on the top? That top's just getting what? Bigger and bigger and what? Bigger. Now, I'm not saying infinity's a number because it's not. I'm just saying the top's getting what? Bigger and bigger and bigger. Now, what happens when you take those bigger and bigger and bigger numbers and divide by 6? It's still getting bigger. I'm just doing what to it? Slowing it down. So this answer is still what? Infinity. Is everybody with me? Did I get a number answer? Then that thing doesn't have a horizontal asymptote. Now, there are going to be 2 different questions on your homework. Sometimes they just want you to do the limit. If they want you to do the limit, they're not asking about horizontal asymptotes. You're just going to get an infinity answer or a number answer. Is everybody with me? Now, let me ask you this. What if this were negative infinity? That's negative infinity, and that's what? Negative infinity. What would happen up here? It would be negative infinity. Is everybody with me? And that would be what? Negative infinity. But what if this were a 4 and that was a negative infinity? Well, if that was a 4, what would this be? X what? Square. What happens when you put negatives in there though when you square them? You see what I'm saying? So don't think they're always going to match, because what? They won't. Now, what are we going to do with all that? Well, real quick, here's what we're going to end up doing with it. I want a rough sketch of that graph. Okay. Well, the first thing I'm going to do is put my asymptotes on it. Do I have any vertical asymptotes? Yes. Yeah, what are they? -2 and what? +2. So I'm going to have a vertical asymptote at 2. I'm going to have another vertical asymptote at -2. Do I have a horizontal asymptote? Yeah, where is it? 1. They're my asymptotes. Then I'm going to put any points that I know. Well, here's my problem on this graph. How many points did you find in all of that work? How many? 1. What's the only point you know after all that work? 0 what? Negative. That's not a lot to work on. Everybody with me? So the only thing I found was 0, -1/4. That's the only graph. I'm not comfortable with that. That's just not enough for me. Maybe it's enough for you, but it's not enough for me. So I'm gonna go by hand on that third test to make a cheat table. I'm gonna need some other values. I'd like to know what's happening right here. Maybe I might try 1 and what? -1. All right, what if I put 1 in there? What's 1 squared plus 1? What's that gonna give me? 2 over 1, what's that gonna get me on the bottom? Negative what? 1 squared minus 4, what's that get me? -3. So what do I get, a negative what? 2/3. Is that below or above a -1/4? That's what? Below, isn't it? And a negative is gonna be the same thing, isn't it? Now, you might decide you want to keep going and do like a -1 point, positive 1.5 and a negative, right with me? Now, here's why I don't have to do this. What kind of symmetry is this? Remind me. It's what? Y-axis. What do you check? How did you check y-axis symmetry? You replaced an X with a negative X and you got the same what? Answer. I don't have to do all that arithmetic. Well, let's try maybe a 3. Is everybody with me? Let's see what happens when we get a 3. What's 3 squared? 9 plus 1 is what? 10. 3 squared is 9. What's 9 minus 4? 5. What's that come out to be? 2. All right, so 3, 2. So what's going to happen if I plug in -3? I'm still going to get what? 2. That's the beauty of symmetry. I don't have to do all the arithmetic again. -3, 2. Now, you may try 4, 5, 2.5. Is everybody with me? But here's what I know. I know this thing's supposed to concave down between -2 and what? That's like a cup sitting which way? Down, right? I bet it goes like that. You see what I'm saying? Now, isn't this a vertical asymptote? Isn't this a horizontal asymptote? Aren't you supposed to be approaching asymptotes? Now, again, I probably would do like a 1.5 and a 2.5, everybody with me, to make sure I'm good, but do you understand probably doing this? And this one's probably doing what? That. Now, let's go back and see if that matches our increasing, decreasing. It's supposed to be increasing from -10 to -2. Is that thing going up? Then from -2 to 0, it's still supposed to be going what? Up. Then it's supposed to turn and go what? Down. Then it's supposed to keep going what? Everybody with me? Where's homework on that? And this is all we're going to do on Thursday. We're going to put you in groups and let you play with them. But that's the big problem that will be on your test. You'll do one everything to it. And then sketch me the graph.